P6 potential dividers. The potential dividers are pretty much a way to pull out some voltage. So pull out voltage out of the main circuit. Now, why do I say voltage? Well, think about the fact that voltage is also called potential difference. So the name potential divider, it means that you're dividing the potential. Now, what kind of potential am I talking about? Well, let's do a diagram. It's going to make much more sense. So we have a series circuit. Remember, in a series circuit, voltage, if this is 1, that's resistor 2, V, this is voltage that's coming in from the source, plus minus equals V1 plus V2. So voltage is divided. Now let's say, so what is this pull out voltage? Well, I'm gonna make an insertion in the circuit next to the second resistor that will allow me to get some voltage out to use it for another device, for example. Now, how do I know how much voltage will I get out? Well, it's always based on the first resistor, is based on the second resistor, and it's based on the voltage that's coming in. So voltage out is gonna be this formula. The second resistor, this is related to the voltage coming out, over R1 plus R2 times V in. So the voltage coming out depends on the strength of these two resistors and the voltage that's coming in. So this is the original voltage, and that's the current that's moving through the circuit. Now let's get an example. Let's say R1 equals 12 ohms, R2 equals 18 ohms, and V in, let's make this 6 volts. What will V out be? Now, if I'm looking at the equation, I will say V out equals R2. Well, R2 is 18 ohms, so we have 18 ohms over, well, R1 plus R2 is 12 plus 18. It's going to be 30 ohms times V in, which is 6 volts, 6 volts. Now, ohm with ohm cancels each other out. So we're going to have 18 times 6, which is 106, divided by 30, is going to be 3.6 volts. So I find out that in this situation, I'm able to pull out 3.6 volts out of the main circuit, out of the V in, out of the main circuit, to use it for something else. Okay, now let's see a special case when the potential divider, so I'm going to say potential divider used with the help of a variable resistor. Now we know the variable resistor is also called a rheostat, and we know that this is a device that has practically a long coil, and then you have a slider that you can move in different position on the coil, and you'll get different resistances, from a very small resistance, so resistance is minimum when you have a length that is minimum, like this would be the top situation, for example, or to a resistance that is maximum when you have a long length. Think about it. We already discussed that the resistance is directly proportional to length. Long length, high resistor, short, small length, low resistance. Okay, so let's do a diagram. The same, exactly the same circuit as before, just the second resistor will be a variable resistor. So plus, minus, resistor 1, resistor 2. This time, let's say V that's coming in, this will be 12 volts. Let's make the first one 10 ohms. The second one goes all the way from 0 to 10 because it's a variable resistor. So we have R1 equals 10 ohms, R2 equals, well, anything from 0 to 10 ohms, depending on how we're moving the slider. V in equals 12 volts and V out equals question mark. This is what we're looking for. So we're looking for this voltage that we'll be able to pull out at this point. Okay, let's get through a situation. You see the first one doesn't change, so we're only changing the second one. Let's say R2 is max. That means let's make it 10 ohms. Now, if I'm looking at the formula, V out equals R2 over R1 plus R2 times V in. Well, let's use the formula. We say, okay, how much voltage do I draw out? Well, R2 is 10, R1 will be 10, so this is half amp. We should get out 6 volts. Well, let's see. R2 equals 10 over R1 plus R2, 10 plus 10 is 20 times 12. Well, 10 times 12 is 120 divided by 20. 6 volts, exactly as we predicted, because R2 was 10 and R1 was 10 ohms also. So everyone gets, both of them get 6 volts. Remember, this is a series circuit where voltage is V1 plus V2 is shared between. Not equally. In this situation was equally because they're equal in the values, but usually they're not equal. Now let's see when R2 is somewhere in the middle. Let's make this 5 ohms. R1 is still 10 ohms. Let's calculate the voltage that's coming out. Well, on the top I will have R2, that means I will have 5. On the bottom I have R1 plus R2, 10 plus 5 is going to be 15 times 12. Well, 5 times 12 is 60 divided by 15 is going to be 4 volts. Number 3, let's make this, in this situation, minimum. Let's make this actually 0 ohms. R1 is still 10 ohms. Now in this situation, I will have V out is, well, it's going to be 0 because R2, R2, not R3. R2 is 0 over, well, 10 plus 0 times 12. 0 times 12 is 0, 0 divided by something is 0. So in this situation, I have nothing coming out of the circuit. So again, potential divider, you're breaking, you're taking out of the overall initial voltage, you're taking out something to use for another part of the circuit.